Hello everyone. Now today let us discuss the physical properties of alkanes. Now some of the physical properties of alkanes are nature of the alkanes, the boiling point, melting point, solubility and density. Now first let us discuss nature of alkanes. Now the nature of alkanes are non-polar. Non-polar, why are alkanes non-polar? Why? Now here we see electronegativity of hydrogen in alkanes. Hydrogen and carbon, they are almost the same. Therefore the effective there is since the electronegativity between hydrogen and carbon is almost equally the same, the effective nuclear charge does not generate much, and therefore since there is very little difference in the electronegativity between carbon and hydrogen atoms, they are non-polar in nature. Now the boiling point. One important point to be kept in mind is boiling point is directly proportional to the molecular weight or the molar mass of the molecule. Therefore, in alkanes, mostly they are saturated, no double or triple bond. Now, as in alkanes, as the number of carbon atoms increases, that is for carbon 1, from carbon 2, carbon 3, 4, 5, 6, and 7, 8. As the number of carbon atom increases, the boiling point increases. Now, boiling point increases. Therefore, it is very easily it can be understood easily here that with the increase in the number of carbon atom, boiling point increases. Therefore, our methane, our first saturated hydrocarbon is known as methane with one carbon atom, will have the least boiling point, and then carbon number 2 would have more boiling point than the carbon number 1. Carbon number 3 would have more boiling point than carbon number 2, and so on. Now, if there is branching in the alkanes, now it is said that boiling point is inversely proportional to branching. Therefore, if there is increase in branching, if branching is increased, boiling point decreases. Therefore, if we consider straight chain aliphatic hydrocarbons, that is our straight chain aliphatic alkanes, with a branch chain aliphatic branch chain alkane, then the boiling point of the straight chain would be more than that of our branch chain alkane. Therefore, we can conclude that if the number of carbon atom increases, boiling point also increases. But if branching occurs in our alkanes, then the branch alkane would have less boiling point than the straight chain alkanes. Now, how about melting point? Now, melting point increases with increase in molecular mass, but however, as compared to the boiling point, the increase is not so very regular. In boiling point, we see that the boiling point increases with increase in molecular weight, but for melting point, however, even if the melting point is increased, the increase is not so much as that of the boiling point in alkanes. Therefore, alkanes with even number of carbon atoms. Therefore, alkanes with even numbers means carbon number 2, carbon 4, carbon 6, carbon 8, carbon 10, carbon 12 will have the alkanes with even number of have more boiling point. They have more melting point. They have more melting point than their previous and next carbon alkanes. That means the carbons with even number of alkanes with even number of carbon atoms will have more boiling point. No matter where they are, they will have more boiling point than their previous carbon atom. That is, previous would be your odd, because if we consider 1, 2, and 3, our even carbon atom is here. Therefore, this even carbon atom would have more boiling point than that of the carbon number 3, the next and the previous carbon atoms. Therefore, the melting point would be in this order. This is carbon atom with the alkane with 2 carbon atom would have more boiling point as that of the next and their previous carbon atoms. Now, solubility. Now we know that like dissolves like. Therefore, solubility, since alkanes, we have discussed here the alkanes, they are non-polar in nature. Therefore, since they are non-polar, alkanes will dissolve in non-polar solvents like ether, benzene, and CCl4. Now density. Now alkanes, since they are saturated, they have no double or triple bond. They are the least dense amongst all organic compounds, as we compare that with that of alkenes, the double bonded, and alkynes, the triple bonded. Therefore, alkanes will have the least density amongst all the organic carbon compounds.